Hi, everyone, and welcome back to In the Kitchen Conversations on IoT. I'm your host, Kerry Siggins, CEO of Stone Age Holdings, which is the parent company of Breadware. And today I have Bryan DeBois with me. He is the Director of Industrial AI at RoviSys. And we're going to have a fascinating conversation about what is happening with industrial AI and how it's going to disrupt IoT. So, Bryan, thank you so much for joining me on the show today.
Yeah, thanks for having me.
Absolutely. Okay, so give us a little bit of background about yourself so people know who you are and how you got into industrial AI.
Yeah, so I started at my company, RoviSys, I actually co-opted there in 2000 and then started full-time in 2002. And so I've actually been at RoviSys for about 21 years now and started out, my background was software, started out programming for RoviSys and then worked my way up. And then I was managing software projects and then moved into management. And then in 2019, we launched this industrial AI division. And I was fortunate enough to be chosen to run that division. And so I've been doing that for the last 4 years. RoviSys, a little background on us. We've been around for about 35 years now and we are an OTSI. And so for your listeners who may not know that term, because I tend to use it a lot, OT is operational technology. And so that was a term coined back by Gartner actually in 2006 because they needed some term. Everyone knew what IT was, and they needed something to kind of distinguish what kind of happened in the plant floor when you're making things move and change and you're making physical changes and equipment and assets. There needed to be a different term. And so they came up with this concept of OT. So we're an OTSI. We work primarily in that manufacturing and industrial space.
So, for people who don't understand what OT means, OTIT means, so can you tell us what the acronym is and give us a little bit more context about what you mean by that?
Yeah. And there's a lot of these terms in the industry and they kind of get all jumbled around. So you got IT, which kind of everyone understands information technology, right? And so those are servers and that's the world of email and business systems and things like that. And then you have OT, operational technology. And so that's the world that we operate in. And typically you're making a physical change in the world. You know, you've got assets, you've got equipment, you're making changes you're producing things. You may be, in the case of a pipeline, you may be moving product through a pipeline, liquid natural gas or petroleum products and things like that. And then you have IoT, which is the O means something completely different in that Internet of Things. And so those are those devices. And of course, you have lots of expertise in this area for those devices that we use oftentimes in the OT world to collect sensors and things like that, to collect all the data that happens down on the plant floor.
That's great. So I'm super curious. How is AI really changing the way manufacturers, these big industrial companies are operating? And how are you helping them advance their technology goals or ultimately their AI goals?
Yeah. Well, more recently, there's been a big, I think, inflection point that has happened in this space. And it may not be the one that most people are thinking of. So when people talk about huge jumps in AI, everyone, of course, nowadays thinks right to ChatGPT. But there was a bigger improvement that happened in the world of OT that started around 2016. And that was the invention of deep reinforcement learning or DRL. And what DRL was able to do, and originally it came out of DeepMind, which was a Google spinoff, and originally it was used to play games. That was what they had developed it for. And so they played Atari games and they played chess and they played Go. And they were able to beat all of our best grandmasters in these games. And they were able to beat all of our best software that played these games as well. And so, and what it was able to do was it was able to learn by doing. So you were able to build simulators and it was able to play, chess over and over again, thousands of times, hundreds of thousands of times, the equivalent of 100 years of becoming a chess master and to learn every time it played to get better and better and incrementally better. And so what we've been able to do is to take deep reinforcement learning and apply it to the types of problems that we have in the industrial space. And that has been absolutely incredible. We're seeing 2, 3, 5, sometimes 10% double digit improvement on processes that have already been pretty well optimized, processes that may have been around for 30 plus years and really you've gone through Six Sigma and Lean and some of these processes to really squeeze everything you can out of it. But there were parts of the process where you still had to have human involvement. And whenever you have that happen, you have expertise in those humans and, that expertise, it goes on vacation, it may retire. And so you have less experienced operators that come in And so what we're able to do is to capture that knowledge and to be able to build a neural network. We call it a brain when it's been trained in this particular way, to build a brain that can step in and operate that process at least as well, and in some cases better than those expert operators. And so that's where we've seen such a huge improvement. In the past, in industrial AI and some of the stuff that we were working on when we first started in this industrial AI thing was the type of stuff you've heard about: predictive maintenance, predictive quality, predictive analytics. And those are great. The disadvantage that they have, though, is that I can build a neural network that can predict a value, but that's all it can ever do. It can predict one value. How many
Mhm.
days until this piece of equipment goes down? What is the final quality of this batch going to be? One value. And then whatever the operator does with that value, that's where you get the actual improvement, right? So if they ignore it or it doesn't really translate and they're not, that's what I always tell customers. I'm like, we can do this whole project and we can operationalize this and we put it on the plant floor. But until somebody is taking an action based on that value, then you haven't seen any ROI at all. Everything that came before that is a giant science experiment. And so we want to make sure that people are actually able to take decisive action based on this. And that's what these DRL types of brains can do, is they can actually make a decision based on the current state of the system.
Absolutely fascinating. So, give us an example so that we can picture it in our heads. Solve a customer problem that you've had as an example.
Yeah, and I've got a couple of them. And the cool thing about it is that they're very different use cases, and yet they're all using the exact same underlying technology to solve the problem. So for one, we had a paint manufacturer, and they needed to do production scheduling. Now, production scheduling it's an old problem, and it's a very common problem in manufacturing, right? You've got these assets. I need to make these orders. What's the best way for me to sequence these orders and leverage these assets? And you've got things like assets that go down in the middle of the day, and you've got maybe labor shortages where you can't run a specific asset because you don't have enough people to run it that day. You got all these different, very dynamic things that are happening, and you're trying to make on the fly decisions. And so typically you have, as this company did, like I said, they're a paint manufacturer. They had they had a couple human production schedulers, right? And they had two that they considered their experts, and then they had some kind of up and comers. But those expert ones, they have to go to bed eventually. This is a plant that runs 24/7, and they have to go on vacation. They've got issues, they get sick. And so their challenge was that their best production scheduler took about an hour to put together an optimal schedule. And typically in any given day and they would put together an 8-day schedule. And typically by about day 2, that schedule wasn't worth very much anymore because there were so many things that had changed and so many, this order ended up taking longer to produce and whatever. And so we were able to build for them a brain that could build a schedule in minutes instead of hours. And so they actually were able then to be able to reproduce a schedule dynamically as things changed and be able to make those decisions. And they were able to use it as a learning tool. So those up and coming human schedulers could start to understand why you would build a schedule in a certain way. So same underlying technology, that deep reinforcement learning. We package that up, by the way, in a terminology called autonomous AI, which is really a methodology that involves DRL, but then there's other aspects too, and we can get into that. But another example is we've got a customer that's using this in bottle manufacturing and using it for shaping the glass, the molten glass, to make sure that they can make optimal bottles based on that. And we've got a customer that's using it in a refinery for refining diesel fuel. And that these are all scenarios where, when you draw diesel fuel out of a distilling column, you can draw too much and it'll start to pull down the product that's on top or pull up the product that's on bottom. And in all these cases, you've got a well-trained operator, in some cases 5-10 years of training, that's turning these knobs ever so slightly. And really it's as much an art as it is a science. And so we're able to build a brain then that is able to manage those same types of competing goals and make those types of human-like decisions.
Yeah, that's so interesting. And what is the ultimate goal of all of this? Obviously, people are trying to solve these real life challenges, but there's maybe a different end game here, whether they know it or not. And what do you think that end game is when this is all said and done?
So everyone talks about how we're in the fourth industrial revolution, right? And what does that mean and where are we going? So my personal take on it is that when we get to the end of this, and hindsight's 2020, but when we get to the end of this, we will say that the fourth industrial revolution was about bringing AI to industry. I really do feel like that is going to be the final goal.
Mm.
But one of the things that I get asked a lot, and so I try to address it head on, is people are concerned about, are we putting people out of work, or is AI going to take away these jobs and things like that? I think it's really important to understand, and people from the outside may not realize this, but in our world, in this world of industrial, they can't find enough people to do these jobs.
Mhm.
And the turnover is really high. So it's not a question of we're replacing people. The question is, I was talking to a vinyl manufacturer about a month ago, and we had built an ROI case around building a brain to run his process. But he said, honestly, he was like, I don't even really care about the ROI, the financial ROI. He said, my two best operators that know how to run this line are probably about 5 years from retirement.
Yep.
So for him, it's existential. Like, he can't run this line. He said, I don't have anyone on the bench. I've got a bunch of guys that are 1 to 2 year guys. There's real high turnover. No one's real committed to becoming an expert. His best guys had spent 10, 15 years becoming experts on how to run this vinyl line. Nobody wants to invest that kind of time anymore and energy to become an expert. So he's saying for him, it's existential. I have to have this. I have to capture before they retire. I've got to capture the expertise from my SMEs, and I've got to put it into this brain. And so that's really the world that we live in, is they can't find enough people to do these types of things.
It's exactly the world I live in too. Stone Age Tools, one of the companies that's part of our family of companies, we make industrial cleaning equipment, and we are moving more and more to robotics and IoT solutions. And it's that same thing, is no one's going to do this work. And every single thing, every single industrial facility in the world has to be cleaned. You would not have all the things that you use every day, the plastic in your bottles, the tires on your car, the gas in your car, the glass in your iPhone, if you didn't have a industrial facility that had regular maintenance on their assets. And that's what we do. But nobody wants to do this work. And we're all across the whole industry, whether that's with the contractors performing the work or the operation, maintenance, and safety personnel within each of these big industrial facilities, they're losing that knowledge. And
Right.
so it's, how do you make that leap? And sometimes it can feel overwhelming, but you're spot on. It's the exact challenge that we know we're solving. Obviously, we have to do things safely and efficiently, but we think the real problem is going to be labor.
Mhm.
And that's the real problem that our products have to solve when this is all said and done, is what do you do when nobody wants to do this work?
That's right. And I'll add one more thing to that. One of the other questions I get is, are people standoffish and do they not want to help with these projects, because do the experts not want to help because they think that we're threatening their jobs or whatever? And I see the exact opposite. We worked on a pipeline project, another production scheduling. Production scheduling of a pipeline is insanely complicated because the pipeline can never be empty. So you always have to have the next product pushing the one before it. And it's a really hard problem. And we were building a system to replace their production scheduler, who once again was retiring. And he got really excited about the project because he saw this as his legacy. He had built over 20, 25 years, something like that. He had built expertise, and he'd become their
Yeah.
best production scheduler on how to schedule, probably one of the best in the world, I would guess, on how to schedule a pipeline. And I mean, such a niche area, but so well refined. He was the expert in this, and he saw this, building the system, as his legacy to pass on as he retired. So he
Yeah.
was super excited to be a part of that project. So really, it's almost the exact opposite of what people think around
Yep.
their stuff.
Yeah. That's a great point. All right. So let's go back to something that you said previously, autonomous AI. So I
Yeah.
would love to learn a little bit more about what you mean by that. Can you
Yeah.
explain it?
Yeah, sure. So autonomous AI is RoviSys approach. It's our methodology to solving these problems with DRL. So DRL is a part of it, but it's not the whole story. Autonomous AI as a concept, actually, that term was coined by a guy named Ken Sanderson. And he was former Microsoft. He actually consults with RoviSys now. And he wrote a book a few years ago called Designing Autonomous AI. And it's an O'Reilly book. And so we really built our AI practice around that and around the concepts there. And so DRL is part of it, deep reinforcement learning. That was the technological breakthrough that made all this possible. But there's more to it. The second phase, or the second aspect of it, is what's called machine teaching. And the idea there is, instead of it's tempting to just give the DRL a blank slate. And there's simulation as part of this too. So you play with the simulator and you just figure out the best way to run this line. So that's tempting. Problem is, that's not even how you would teach a new operator how to do it. Like, you're going to sit them down, you're going to say, okay, this is how we typically do it. And if you see this state or you hear this, you smell this, or you're seeing this rev up a little bit, then you're going to make these changes. If you're in this state, you're going to run it this way. And you're going to walk through different scenarios and heuristics and whatever. Capture all of that from our experts. That's really where we grab that expertise and
Mhm.
we put that all into machine teaching. And we build a graph actually of how to handle all these different scenarios. It's going to look like an SOP that, standard operating procedure that an operator would get maybe on his first day. It's very similar to that. And we're going to feed that into the DRL so that the brain has a starting point. So that's the second aspect, is machine teaching. The third aspect, as I said, is simulation. So what's unique about DRL versus any other machine learning is that it learns by doing, not by data. So we actually will either leverage a first principle sim if the customer has that, or we'll build what's called a data-driven model, which is a simulator built off of data they've already captured in their historian or whatever. So we're going to build a simulator because that's what the brain has to be able to play. And so that's where it's going to play and it's going to make its mistakes, and we're going to slap it on the wrist and it's going to figure stuff out and we're going to reward it. And then the fourth aspect is all of the existing optimization technologies and control technologies that already exist. We can actually, the very cool thing about this is when we're doing the machine teaching, we can actually incorporate things like rules-based systems that have been around for a long time. We can incorporate control theory, traditional, think PID controls. We can incorporate that into it. At each step of the process, maybe DRL is the best choice there, a mini brain, but maybe not. Maybe we already have a solution for that with an existing rules-based system. So we can incorporate all of those existing optimization technologies and tools. We may build at one point, one of the examples we have is, so it was galvanizing a steel line, it was applying zinc, and they use air knives to spread it, and it makes different visual patterns. And so we were able to build a camera that can look at those patterns. And then we send it through a very traditional computer vision system, not a DRL
Mhm.
based system or anything like that, that just classifies the patterns. So it's really good at doing that. So why build a new system? There's already existing systems. And then you pass the classification on to the DRL. And that's all it needs to know. Oh, it's the fishbone pattern. It's this pattern. It's that pattern. And it's able, just like a human, if you're training a human operator, you'd say, okay, now we're looking at fishbone. Now we're looking at this pattern. Now we're looking at that pattern in the zinc. And then it can make decisions then based on the state that you're in. So those four aspects of it, DRL and machine teaching and sim, and then incorporating existing control strategies, those four things make up autonomous AI.
I love it. I love it. I can imagine it brings tremendous value to your customers because it gives a little bit more concrete. This is what the process is. And oh, by the way, it doesn't have to be this pie in the sky. We're going to invent everything from scratch, which I think certainly that's something that I would be interested in as a CEO of a company looking to advance technology within my own company. Let's not reinvent wheels if we don't have to.
Well,
Mhm.
and I think that it brings a certain amount of credibility. So
Yeah.
one of the things RoviSys has learned over 35 years doing this as an OTSI is that if you come in and you say, yep, we're going to rip out everything and we're going to replace everything, you're not going to get very far in the conversation with our
Yeah.
customers. And oftentimes what we see is the big IT consultancies that are moving into our space. That's what they're saying and you can imagine which companies I'm talking about, but they're going to come in and they're going to say, give us 20 million and we're going to rip out everything you have and we're going to replace it. And our customers are like, yeah, no, we're not going to do that. So there's a certain amount of credibility where we often at times are like, keep everything you have, unless you really want to replace it. But if it's
Yeah.
working for you, you're still within support or whatever, keep everything you have. We'll layer on top of it and we'll leverage what you have to bring you to this AI future. And our customers are typically very happy.
That's great. And when you do that, like layer it on top of something, do you do it in a way that if they do decide everything goes later on, then you don't have to redesign this
Oh, for
autonomous
sure.
AI on top of it? Yeah.
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 Oh, for sure. Yeah. And it's not as hard for us. It's not as hard as some people may think that it would be. We can build these things in a way where, yeah, it's absolutely not a problem, where they're upgrade proof, they're future proof.
Yeah.
And so you can still, and they would actually benefit then as you modernize. Let's imagine a line that's 20 plus years old and that over time, they want to start adding some more sensors and some
Mhm.
things like that. I could imagine a situation where suddenly now we can see more than we could before because we've got more instrumentation on this line than we had when we first put the brain in. So we can actually retrain the brain. It's actually fairly easy to retrain the brain and add those new sensors into the simulator, retrain the brain. And now suddenly the brain's smarter and can see
Yeah.
more than it did before. And that's the type of thing. That's where you get those incremental improvements and continue to get an extra 0.5% yield or percent reduction in scrap and those types of huge, big ROIs.
Yeah. So bringing this all back to IoT, Do you think that 10 years from now that IoT and AI will be separate, or is this going to be synonymous because it's what it's doing, at least in this at least in this form that we're talking now?
Yeah, I mean, I think that they will very much be melded. I think that
Yeah.
if you accept the premise that, the direction that we're going, what we're trying to do with Industry 4.0 is get to an AI future. IoT
Mhm.
is the eyes, ears, nose. It is the senses of that AI.
Yeah.
And so it starts to become pretty obvious. And we're already seeing that. The first thing that we do when we go in is we look at the historical record that they have, all the data that they've already collected. And the first thing we say, is there enough data there? Or do we need to add more instrumentation or more sensors
Mhm.
and
Mhm.
augment that data before we're actually going to be able to have the AI be able to do anything? And yeah, I mean, the IoT becomes a very intricate part of that whole story right
Yeah,
from.
absolutely. Well, I could talk about this all day with you, but we're wrapping up on our time here. So I'm sure people are going to want to reach out to you and talk to you about this. So how can people find you? How can people, yeah, send us your way?
Yeah, rovisys.com/AI.
Yeah.
So Rovisys is ROVISYS.com/AI. It would be the website. And then they can always find me on LinkedIn. It's Bryan DeBois, BRYANDEBOIS. Look me up on LinkedIn. I'm happy to connect with anyone. And yeah, yeah,
Awesome. This has been fascinating. Thank you so much for coming and sharing your expertise, Brian. We'll include all of that in LinkedIn, on YouTube, and on our website. So anybody will be able to just click on it to be able to get to you.
that
But
sounds good.
this has been fascinating. Thank you so much for coming on the show today.
Thank you. It's been a pleasure.
Thanks, everybody. We'll see you next month. Take care.